Hi everyone, in this video I would like to talk about the chromatic number of a graph. So the chromatic number has to do with graph coloring, and I'd like to do a few examples first and then we'll come back and talk about what is the chromatic number. Okay, so I'm going to look at the graph over here on the left, and what I want to do is I want to color the vertices in a way so that no two adjacent vertices have the same color. All right, so let me show you what I mean by that. I'm just going to select some colors. So suppose I color my first vertex here red. All right, so I've made that reasonably clear. And then I need to go over to the adjacent vertices, the neighbors of this red vertex, and when I need to choose a different color. I can't put red there. I don't want two colors, I don't want two vertices of the same color to bump into each other. So if I chose red there, I need to choose a different color like blue for this one over here. And then if I go over to the other two neighbors of red, I can choose another color. So let's see, well, blue is still available. And the reason that that's available is because these two blue vertices are not neighbors. They're not adjacent to each other. So there's no conflicts or clashes or collisions going on there with the blue. All right, I've got one more vertex to color, and let's see, this one that's uncolored is connected to red, so I cannot choose red. And it's connected to a blue vertex, so I cannot choose blue. I need a different color. I need a third color here. So I'm going to choose green. Oops, let me fix that. That one was blue. Okay, so now I'm going to choose a new circle and make it green. So the idea here is that I am coloring the vertices so that no two neighbors have the same color. And if you look at what we did for this particular graph, this required 3 colors to avoid collisions or to avoid color sharing. I'm going to say collisions. And that's really what we mean by the chromatic number. We're really looking for the minimum number of colors needed to color a graph so that neighbors don't share the same color. All right, so let's write that down. So the chromatic number of a graph is the minimum number of colors needed to color vertices so that no two adjacent vertices, in other words neighbors, no two adjacent vertices share the same color. Okay, so now looking at the graph on the right, we have a complete graph. This is K5. It's a complete graph on 5 vertices, meaning that if you pick a vertex, it is connected to every other vertex in the graph. And if you look here, every vertex has degree 4. So what this means is that we are going to need to choose many different colors for this graph. So if I start off choosing red, then if I look at the neighbors of the red vertex, I need to choose other colors. So let's choose green for the next neighbor here. And now I look over on the left side of the red vertex and I say, well, maybe I could use green here as well. And the answer is no, we cannot use green because this vertex I'm trying to color is already connected to the green vertex, and it's already connected to the red. So I need a third color. Let's choose blue. All right, so now let's keep going. The red vertex has 2 more vertices as neighbors, so I'm going to come down here to the lower left corner, and I can't choose red because it has a red neighbor. I can't choose blue because it has a blue neighbor, and similarly I cannot choose green. So we need a different color altogether. I'm going to make it pink. And we've got 1 more vertex to color. Similarly, it cannot be any of the colors already selected. So I need a 5th color. I'll make it purple. And so the chromatic number of this graph was 5. Okay, and so that's what we mean by the chromatic number. So on the left, we have a chromatic number of 3, and on the right, this graph has a chromatic number of 5. Hi everyone. So I've switched gears here and want to look at a scheduling problem. So in this situation, we have several classes to offer, but a limited number of classrooms. So we want to figure out the minimum number of classrooms needed. And unfortunately, we have a further constraint that the same instructor teaches some of the classes, and so certain classes cannot be offered at the same time. So what is the minimum number of classrooms needed for the following? So we've got an algebra course, and that is going to conflict with geometry and trigonometry. We cannot offer algebra at the same time geometry or trig is offered. And similarly, geometry conflicts with calculus and algebra and so forth. So one way to work on this type of problem is to draw a graph. So I'm going to draw 5 vertices. Oops. So there we go. And I'm going to label the vertices. And now I'm going to connect vertices that have conflicts. So for example, algebra will be connected to geometry and trig. Geometry will be connected to calculus. And, well, algebra, we already have that recorded. Calculus is connected to geometry as well as trig and discrete. Discrete is connected to calculus and trig. And trig is connected to discrete, calculus, and algebra. Okay, great. So now we're down to a graph coloring problem, and it's the same idea where, we wouldn't want algebra to have the same color or the same time slot as geometry and trig because we cannot offer all of those classes at the same time. So let's say I put, oops, sorry about that. Let's say I put our algebra course in the morning, a morning time spot, and I'll call it red. Whatever time period that went into, I need a different time period for geometry and trig. So it can't go in the morning slot that's designated red. I need a different color. So let's choose yellow. And notice that geometry and trig are not connected. I could offer those at the same time. So I could put those both in the yellow time slot. Okay, now we need to look at the neighbors of trig. So trig connects to calculus, and calculus does not connect to algebra, so I need a different color than yellow. I could make this red, for example. But then if I look at discrete, discrete has a neighbor that's yellow and it has a neighbor that's red, so I can't use any of those colors. I need a different color. So let's use purple. And what this says is that I need 3 colors, or 3 different classroom times to hold these classes.